Hi, and in this video, we're going to continue our focus on the environments and sticking with our rocks for one more video. We're going to do a couple of things to sort of get to the final stage of the rocks before moving on. In this video, we're going to touch on 4 topics. The first being simplifying the mesh, reducing the triangle count to improve draw performance. We're going to talk about the use of the complex collision channel as an alternate to the simple collision channel for foot placement and basically being able to navigate within the world. Then we'll talk about landscape blending and the use of runtime virtual textures to blend our meshes and our landscape together. And we'll wrap it up with a discussion on the performance considerations when building out your world, using stat unit and the GPU profiler to look for bottlenecks and know where to go address those issues. So let's jump right into it. So we're in our main project, gone ahead and imported those rock assets into our folder. And the first thing we're going to do is we're actually going to simplify the mesh a little bit. So if you hover over any of the meshes, if you're using the same pack that I pulled in the previous video, this one has about 700 triangles. And what we're going to do is, so I've copied it. This one still has 700 triangles, but I've called it Simplify. So I'm going to drag the original into the scene. And I'm going to drag the not yet simplified. So at this point, they are identical. They both have 700 triangles. It's just a simple copy. This is our simplified one. This is our original. We're going to select the simplified one, go to modeling, go to mesh, and go to simplify. When we do that, by default, it's going to cut the triangles in half to 50%. You can play around and try to fine tune it even more. But for this, I'm just going to hit 50% and see if saving half the triangles has any issue with the way we see it in game. Okay, now let's go to our content drawer and we'll see that this now has 360 triangles versus 700. Let's save that. And so this is 700 triangles. This is 360. And if we get up close, they don't really look any different. They're still the same shape, size, complexity. And for cutting the triangles in half, that's probably a reasonable adjustment. You see a little bit of difference here. So here you see this sort of flatter location. Here it looks like there might have been a triangle bump out here. See how that is slightly different than that. But at this scale, it's probably worth those few little adjustments. All right, so now let's take both of these and let's rotate them so we can get our character up close and personal. I'll push them down into the ground. All right, so we should be able to let's go back to select mode. This was our simplified. This was our original. A little bit. And let's play. All right. Original, simplified. I think the reduction is worth it. If it's probably too high to jump on. Too high to jump on. Foot placement seems fine. So that's the first optimization. We reduced the number of triangles. Now we're also using a technique on these particular rocks that I find useful when you're dealing with rocks that you're going to blend into the landscape, because your character is going to be walking on them all the time. And that is, rather than building a collision box, so rather than using here and generating a simple collision, we use the complex collision, which is a setting right here. So under the collision presets, you can tell the engine that when this asset is being queried for its simple collision, go ahead and hand it back the complex collision. Now, it's a little more costly to do that, but in cases where foot placement and clipping through the material is problematic, it's a whole lot easier, and the performance costs are really not that much. So if you look at this mesh here, and I will show collision, you'll see that it shows a simple collision, but then it has the complex collision behind it in white. It's actually the complex one that's going to get used. And so what happens is your character can walk through these areas that would ordinarily be green. So if you, let's do this. So let's leave. So this is our simplified. This was our original. So we're going to get rid of our original. Get rid of them both. And let's copy this again. And let's make this one call it collision for now. So in my simplified collision, I'm going to turn that setting off as soon as I can find it. I'm going to go back to the default. I'll look for collision. So this is the simple collision boundary on this one. And note that when we look at the simple under this setting, we don't see the complex. However, if we do it this way, you see both the complex and the simple in the view. That lets you know that that is on. So this one is using a simple collision. And this one is using the complex and simple. So we've got this one, complex and simple, and actual simple. So we're going to pull those two into the world. And that's probably enough. Let's see if I bring them up. Bring that other one over. Let's bring both up first. Now let's play with these. And you see I can't get closer because of the simple collision volume. And so by using the complex and simple, I can actually get right up and get all my foot placement appropriately. So for things that are going to be on the ground like this, where your character is going to be running over them, I find using the complex and simple to be a good trade-off, to not have to go build detailed simple collision boxes to get my character to not do this around an object. So I've gone ahead and put a bunch of those newly simplified meshes into this formation here so that we could run a few tests and see if the character can interact with them properly. Foot placement seems good. all the collision volumes seem to be reacting as I'd expect. And we're able to climb to the top of the rock pile. Now if we exit, and let's go take a look at that. First thing we want to look at is, what does our wireframe look like? So because we simplified the mesh, you can see that there's not a lot of triangles being used in density of the screen. If you compare it to the landscape density, where you have a lot of density, and the water density out here, the rock formation that we've created doesn't have a lot of triangle density. So the drawing of the actual geometry shouldn't be expensive. If we look at the layer collision, we do show collisions, you'll also see that our collision geometry is less complex than our landscape. So this collision geometry, even though we're using complex, because we've reduced the triangles, it doesn't look like that is going to be a performance bottleneck either. And then the last thing to look for is to check our shader complexity. It's not the last thing, but another thing to look for. So let's get rid of the collision. And you'll see that our shader complexity for this is green, which is good. So the overall rocks aren't overly complex from a model perspective. The collision channel is accurate so that we can walk on it. And the material is green in that it is not going to cause problems. So those are kind of game ready, optimized assets. So what we're going to do is talk a little bit about how we make the color matching work in something like this. And we use something called landscape blending. And there's lots of YouTube videos out there. You're going to go look for anything that's runtime virtual texture. You can find anyone. I will find one and link it into the comments below. But basically what we're doing is, in our profile for these rocks, if I get close enough, you can see the landscape pattern is being projected onto these rocks so that it looks the same whether I'm on the rock or whether I'm on the landscape. And the easiest way to show you that is by turning it off. So let's go to my rock material, landscape rocks. And in my landscape blending, I'm going to turn this off and watch the top of these rocks right here. You see they no longer blend with the landscape. So this particular material a little more room. This particular material has these nodes where I have a material function and I can adjust some of these parameters going into it, which is controlled by the Boolean I just turned on and off. And I take the output of my material for my rock, pass it through this blend. Inside the blend, we're basically grabbing our landscape virtual texture, which I'll show you where we create that, and taking the input material attribute, this is the rock, do a quick conversion of our normals, blend those together, either with or without the normal map. And these are some adjustments that deal with the height. So I'll show you the height and the material. So there are two virtual textures. One records the height so that we can do this math. And that defines our blend mode. And we switch it back to tangent space. Again, I will link a video for this. you can easily just watch the original video, and that gets applied to the final rock texture, so that when I turn that on, you see that the tops of the rocks match the landscape, and it actually carries itself all the way up here to the top, with this one exception which I left here on purpose. So all of these rocks have the pattern from the landscape being projected on it. This one does not. And what I found is interesting is you have to get close enough to the landscape for this to work. So if I stretch this thing out enough and it gets close enough to the landscape, there, you see it happened right there. Just a little bit longer and you see it start to paint the landscape. And the reason I had this is I was filling this little hole here. So I wanted to fill this little hole, and then that blends over top of that hole better than if I didn't stretch that out. You see how it doesn't pick up the coloring profile. So just something to be aware of, that if you are having rocks like this and you want to use this technique, make sure that you got your rocks at least coming down close to the landscape. All right, so that's the landscape blend. Oh, I did say I would show you where we picked that up. So in the material for our landscape, which is this one, in parallel to writing the landscape material, we write this runtime virtual texture right here. And in our world, the other thing you need to have is in your world, you have two volumes. One is your height, which specifies where you want to record your height information. And one is your material. So we have these two virtual textures. They're picking up both the height data and the landscape material data, and then we're projecting them on top of these rocks. All right, now let's talk a little bit about performance and understanding where performance is taking a hit. So I've got a couple of stats happening on the right-hand side of my screen. I've got our game thread running at about 6 milliseconds. We're drawing at about 5 milliseconds. And we're running, looks like about 60 frames per second. That might be locked. Let's see if we are. Yeah. So we were locked at 60. So we're now running about 80 frames per second. And you can see the my limiting factor is my RHIT. That's the milliseconds that most closely matches my frame. The frame is the composition of all of those threads. The largest number is the one that's going to result in the frame. It's your bottleneck. So our draw call is not our bottleneck at this moment, nor is our game thread. But we've got our settings set pretty low. So what I'm going to do is use the in-game settings. And let's start by, you can see I have them set fairly low. Let's take our shadows all the way up to epic and apply that. And things still look pretty good. Let's go ahead and take them all to epic. All right, and by setting them all to epic, you instantly see that our draw calls are now 27 milliseconds, and it is now our bottleneck. So we've turned on all the fancy drawing And the quality of our scene is obviously much better, but it came at a cost, and that cost is our frame counts dropped from about 80 to 35. And so what we're going to do is we're going to actually use a command, and that command is profile GPU. And what that does is takes a snap of the drawing and breaks it down for you very nicely into these colored bars. So you can see that in order to create the scene, we have these activities that occur up front. They don't take a lot of time. We have our main scene draw, which takes 95% of our time, and then a couple little things that are happening afterwards here. So if I look at these, you're going to look for the time slices that are taking the most. So here we are. Post-processing is taking 6.7 milliseconds. And then if you want, you can open that up, and you can see here that the anti-aliasing is almost 6 of that 6.7. So one thing we can do very quickly to shrink the size of this bar, which is currently 6.77, is to look at our anti-aliasing quality. Anti-aliasing. So if we take this down, turn it off. Oh, this is why we're getting locked. We're getting locked at 60 frames here. Our draw came down much, but you can definitely see that our post-processing, which used to be almost 7, is down to 2. And the anti-aliasing quality of 0, right, we lowered that way down, is the piece that came down. So by changing anti-aliasing, I can get a significant performance boost, and that lets me know that, okay, there's areas where I can optimize things. Now the next biggest thing is our indirect and ambient occlusion. And if you look at the categories, it's a lot of subcategories. I'm looking for numbers that stand out. So the lumen screen probe gather is most of that time. So we can go look at settings where we may want to reduce the reflective nature in lumens, do other adjustments in our project settings to keep bringing our draw down. So right now, at the settings that they're set, right, we're running at about 20 milliseconds or about 40 frames per second, and I'm on a laptop, so that's not horrible. But you can see that now with the settings set high, our draw call is our limiting factor. So we need to be careful in the assets that we bring in and at the settings that we apply to keep our draw call under control, because that is the one that's going to cause our frame rates to be an issue. As of right now, our game thread is never going to be the bottleneck. So hopefully that helps you troubleshoot your level. I think we're going to wrap this one here, and then we'll pick it up with water. As you can see, we're preparing some water over here in our next video. So thanks for watching.